Hello everybody. Today I'm gonna demonstrate a sampling distribution simulation and then how does the type 1 error will be happening in this simulation. And firstly, we have assumption that our population variance is unknown. In this case, we will use t-test. We use t-test with we use t-test by we use t-test and estimate by the variance will be estimated by sample variance. So firstly, the objective is to test if the population mean is equal to 10. We set our null hypothesis H none. H none is equal to 10, and then alternative hypothesis is not equal to 10. So we want to inference how much chance that our H none is true. The small group, we choose a small group of data, that's our samples. In this case, we choose 30 samples, and then we use the crystal ball function, which has a defined distribution, since we assume they are coming from a normal distribution with mean is 10 and standard deviation 2. Enter. Okay, we can copy and paste this cell. We can only use here to copy and paste. So this is how many. Okay, we can only use this button, so that we have now about 29. Okay, one more. We have 30 samples here. We have 30 observations. This is sample number. This is observations. And here we want to make a note that our assumption parameter is population mean is equal to 10, and then standard deviation is 2. So right now right now we have the samples. They are coming from, we assume that the population has a mean of 10 and a standard deviation 2. But in this inference, the standard deviation, we assume it's unknown. So for the statistic, we will use t-statistic. So the t-statistic formulation is the sample mean minus, let's create a formulation here. The t-statistic is the sample mean minus mu none divided by the sample standard deviation divided by square root of sample size n. Okay, this is our t-statistic equation. Okay, our sample mean will be in the formula average of all observations. That's our sample mean, and the sample standard deviation is our standard deviation formula, sample standard deviation formula of our samples. Then our t-statistic, let's put in the formula there. Sample mean minus or assume this is mu none, and divided by sample standard deviation divided by square root of sample size n 30. Let's see, we have the F10 as the mu none. Here we put the mu none equal to 10. In this case, we can test the use one-step crystal ball simulation. Yeah, we have number here. Okay, these observations are generated based on our assumption, which is normal distribution with the mean 10 and the standard deviation 2. The next step, we want to simulate the type 1 arrow, here we have the t-statistic. For the type 1 arrow, we need to compare the t-statistic with the t-critical value. T-critical value. How does the t-critical value coming from? Here we will use an function t inverse function. It will be this one, two-tail. This will return the two-tail inverse of the t-distribution. Alright. So we will input the probability. We want a significant level at 95%. We want the degree of freedom is 30. Oh, it should be n-1 degree of freedom. That would be 29. Okay. Okay, here we have the t critical value. Sorry, this should be the lowercase t. Then what our type 1 error will be? So the chance of type 1 error, we should be make sense with our t critical value function. Our t critical value is we set a 95% significant level, so that means the type 1 error should be 0.05, 5%. That's our type 1 error. Okay, we make this cell as our forecast right now. We still use the crystal ball function, but we use the define the forecast. Yes. Okay, we need to set a formula for type 1 error. So in what case will occur the type 1 error? It is when our t-statistic, the absolute value of t-statistic greater than t-critical value. That means the t-statistic is outside of the 95% region on the bell shape. Alright. Now we can define the forecast on the cell. Okay, the name will be the probability of type 1 error. Okay. Okay, let's do a step. Alright. Alright. The correct formula should be if, let's put a number, make it, if this happen, if the type 1 error happen, then this cell gonna be 1. If it doesn't happen, the number will be 0. Then as the simulation runs, it will be different trials. In each trials, it will have its type 1 error either happen or doesn't happen. Here we put 10,000 rounds. Let's put 1,000 rounds first. Yeah. Then that means it will simulate 1,000 times for the 30 observations. Let's see in the 1,000 rounds how many times the type 1 error will occur or not occur. Let's start it. Sorry, this is way too much distraction. Okay, this is our number. This should be our result. Let's see, let's take a look at the split view of the statistics. So here we have the frequency chart for the two results of the type 1 error. It's either 1, 0 or 1. This is the frequency of 0 happens. Let's see the left hand side. It's about 950 occurrence of zeros. For the ones, it's about 550 occurrence of 1 happened. Let's put this chart here. See. 0. Zero occurrence. Zero is happen 50 times. 50 out of 900 out of 1,000 times, and 1 happened 950 out of 1,000 times. So that means the frequency of the probability of 0 happen. The probability of 0 happen 0 is 0.05. The probability of 1 happen is 0.95. So what does it mean 0? 0 means our type 1 error doesn't happen. And probability of and what does it mean 1 means our type 1 error does happen. Type 1 error doesn't happen. This is the type 1 error that's happened. Did happen. Alright. So let's look back on our graph. So this is the simulation of how does type 1 error and how do we make the sampling distribution with the t-statistic inferences, and how do we conduct a simulation on type 1 error. What if we change the null hypothesis to 12? Anyone know what can happen? See, we are assume our null hypothesis is 12. That means we assume our sample is coming from the population with a mean 12 instead of 10. We previously assumed this is 10. Let's see, our assumption is 10. See, right now it's apparently we are manipulating a mistake in our null hypothesis. Probably our conclusion will show, probably our analysis will show we have to reject the null hypothesis. So anyone can predict what the type 1 error, the percent of the type 1 error will be? Let's take a look. So if we change this null hypothesis mu, then our t-statistic will be changed. But then let's do one step to experiment. Then we still compare, for type 1 error, we still compare the t-statistic with the t-critical value. And let's do another 1000 simulation. I think this is not coming from, sorry, this is coming from my other workbook. Okay, the probability, now the probability of type 1 error happen is 100%. It's telling that every single chance a reset will happen. It's very big chance. We have sufficient evidence to show that we should reject the null hypothesis. See. Because we didn't set the echelon is the same as our assumption. Let's change our assumption. Become 12. Okay, we we still need to copy and paste for all the cells. Alright, let's do a check. Yeah, it's already 12 here. Then let's do the simulation again. Yeah, the probability of type 1 error, now it's coming back to and now it's coming back to 5%. See? Alright. Thank you everybody watching this. Hopefully it does help you understand sampling distribution with the type 1 error, the logistic about how this is happening on Excel.